Good morning, everyone. So, today we are learning about a small component that controls very big things. So, yes, this is the relay, the superhero of control circuits, you can say that. It's a tiny, but it can switch on fans, lights, motors, and even machines just by small signal from our microcontroller, right? So, we have already discussed this in our lecture as well, that Arduino is very limited. Like it can provide a very small amount of current and a voltages. So if we need to control big things, we need an external device that is the relay. So what is relay? All right, class, imagine this that your Arduino is like your brain, but it's very dedicated. It can't handle big currents. You want to turn on the 220-volt fan using Arduino. So can you connect it directly? Obviously not, right? Exactly. So it will definitely fry the board if you are going to uh, connect the 220-volt bulb with your Arduino. That's it. A relay works like a electrically operated switch. It uses a small current to control a large current. Simple, powerful, and safe. So this is all the theory about the relay. So, I hope you are understanding this concept that if we are going to control our household lights, the lights that we are using in our home, so we can't directly connect them with Arduino, right? So, Arduino is basically working on 5 volt, and our household lights are working on 220 volt. So, there is a big difference between them. So to overcome this problem, we need an intermediate module that is actually a relay. So you can also see the real life example from here that when you press the start button in car, it's not the button that starts the engine, it's a relay. So what is basically relay in simple terms is it's an intermediate device that takes signal from the microcontroller and control a very big things like you can say that cars, you can say that the heavy engines, motors, and all the stuff. So motors usually take a large amount of current. So let's see how this basically works. Inside the relay, there is a tiny coil. When current flow through the coil, it becomes magnetic, just like the magnet you played with, like normally the magnets that are around you usually you try to play with them and all the stuff. So inside the relay there are three basically plates. The middle one is movable and side plates are fixed. So you can see over here as well. So this is like a plate that is movable. It can move towards the NO pin and it can move towards the NC pin. We are going to understand as well that what is NO and NC pin. So here is relays terminology. So common pin is a central plate that I have explained you already. So there are two plates. One is on the left and other is on the right side of that central plate, right? So one is to make the relay on and second is to make the relay off. And there is another pin that provides sufficient current to the coil. So when basically coil get magnetized, it becomes an electromagnet, right? So it attracts the middle pin. Middle pin is a movable pin. So it can move from the common to NO pin or common to NC pin, right? So this is all for the relay. Let me show you how basically relays look like. So this is how the relays, yes. Okay, so there are three pins on the right side and there are three pins on the left side. So left side pins are for the higher voltages and these pins are to provide a signal to the relay whether it's going to turn on or off. So that's it. All right, let's move towards types of relay. So mainly relays are of two types, but you can also categorize them on the four types. So EMR and SSRs. So EMRs are basically the relays uh, that we have just seen on Google. So these relays are basically based on the mechanical motions, right? I have explained that to you that there are three pins. One is movable, that is middle pin, and there are two pins on the left and right side of the. You can say that the movable pin. This all concept is based on the EMR technology pins, electromechanical relays. Second one is the solid state relays. Solid state relays are just like the transistors, but the transistors that can handle a very large amount of current. Usually, the transistor that we have used that transistor on the Tinkercad was a very small voltages, and you can't control directly the 220 volt or the 10 amperes and stuff. So the SSRs must be based on the higher values of that transistors. Okay, so another two types are the single or double channel relays and high current relays. So what are the single and double channel relays? Let's just see. Okay, this is a single channel relay. So there is only a one input and one output, right? So if there is need of two or more outputs, then we are going to use that type. This is a four channel relay. One, two, three, and four. So you can provide a four signals from here, and you can get the output in the four different relays category. So you can turn on and off basically four bulbs in your home by using this four channel relay. So you can understand that in a simple way by the number of bulbs that you are going to connect, that number of motors that you are going to connect with that. All right. So obviously, as I have shown to you that there are two types of, you can say that the terminals that is relay basically is consist of. One is from the input side and another is from the output side. So on input side, basically, we are going to connect VCC with a 5 volt of Arduino ground pin to the ground pin, input pin from the any pin of the Arduino. Okay. So basically, we are going to code and program the Arduino according to that pin, and we can get output correspondingly. So this is the code that we are going to use on the Tinkercad simulation. And what are the applications? Let's see that applications of relays. But before that, let's see the simulation on the Tinkercad. So this is a diagram I just have created for you. So we are going to control this motor with that Arduino, right? So Arduino can't provide a sufficient voltage, or if I'm going to provide more voltages to that motor, it will basically give me a more RPM, right? So currently it's giving 71 RPM. So let's give it 5 volt, 6 volt. So now 6 volt, it's giving me 204 RPM. So I can provide current up to 30 volt from here, right? But our Arduino can provide only voltage up to 5 volt. So if I am going to give some device more voltages than this controller, then I have to use this relay. So this is relay over here. You can see that this is electromechanical relay. So this is a transistor over here. Why I am using the transistor and relay both at the same time is just because this Arduino is providing a very little amount of current, so I have to isolate that as well from the relay and the back currents of that motor. So this is the main reason that I am using this transistor, you can say that. But it's not a compulsion. I can skip that transistor as well if I want to. Let's try to. Okay, now you can see that motor is working perfectly. But this is better to use. Uh, Transistor over here. You can see that a warning over here, the current capacity of this Arduino is exceeding. So that was the main reason that I'm using the transistor. So transistor can help us to prevent this Arduino from over voltages. So let's see the code of that. So it's a very simple code. Yes, you can see that our code as well. If you want to see the text, you can definitely see the text code. So it's LED blinking code on Arduino, but I'm controlling motor that is taking the higher values of current, and how it is possible just because of this relay. So if you want to practice that circuit, you can also practice on the Tinkercad in your homes. Obviously, you are having the laptop or any mobile, so you can definitely do that. So let's get back to our lecture and see the applications of relay. So in our daily life, you have probably seen and heard the click sound of our refrigerators after few time, right? So that click is basically because of that relay inside refrigerators. There are relays that control the turning on and off of that refrigerator based on the temperature. So this is also the device that is using relay in our household things. So in our home, in our home automation, smart lights, fans, and everything need relay to control. And industrial machines like motor starters and everything, they basically need relays. And in automobile, horn, headlights, ACs, robotics, high current motor currents, and safety alarms, smoke, gas, and everything. If you are going to use anything more than the voltage of that controller, you must have to need you basically need that relay to control that and isolate that controller from, mm, you can say that the higher power devices. Okay, so you can also use a DHT sensor, temperature sensor, and everything according to your own need. And if you're going to control the fan, that is based on your temperature. Like if temperature exceeds the 25 degrees, the fan should start automatically. So you need a relay for that as well. We have already discussed all these. Okay, the one most important thing is that, as I explained that to you earlier, never try to operate the relay on the live or a voltage wire that is in your home. So that could be dangerous, right? So safety is the main concern. So safety first. So I have already explained to you that if you are going to control the bulb or fan or anything that is on the alternative current, so you need a supervision of somebody else, of your elder. So you can also test this relay on a smaller LED like 3.5 volt LED in your home. Okay, so these all are the things that we can make with this relay. So that's it for today. I hope you are enjoying the vacations at your home and you are studying as well. So thank you so much.